Lesson 6, finishing up our stretches about the x or y axis, part 2. Review is just the first part here. I'm not going to read that to you. That's just briefly going over last class notes. Just basically, we know that if a is greater than 0, it's a vertical stretch. So that's the a in front of the function. That's a vertical stretch, making it steeper. Okay. If a is between 0 and 1, that makes it wider. Okay. So they still call it a vertical stretch for A lesson 1, but it just kind of makes it a little bit fatter if you think about your parabola example. Horizontal stretch, again, it's 1 over B. So horizontal stretch has that weird thing where you have to flip it. This horizontal stretch is flipped. So if you see on this B right here, if you see a 3, it's 1/3, right? You're doing 1/3, so it's going to get tighter. If you see 1/3, it's going to get wider in terms of stretching out the horizontal. The other thing to review, remember, if you have a vertical stretch, does your x-intercepts change? No, right? Your y-intercepts stay the same. Or sorry, your y-intercept changes. If you have a horizontal stretch, your x-intercepts now change. Your y-intercept does not change. Okay? So keeping those things in mind. All right? Any questions? Obviously, if you have both type of stretches, then you move both. That happens. Okay? But overall, just keeping that in mind. If you have just a horizontal stretch, that means you're changing x-intercepts, not the y, and vice versa. All right, so let's go ahead and look at these, guys. So we've already kind of got the basis for these. So y equals x squared after horizontal stretch about the y-axis by a factor of 3/4. They want the equation for this. So they give you a standard parabola. They said horizontal stretch by the y-axis by a factor of 3/4. So what would it look like? What would you do? Go ahead, Cassie, and then we'll see if Aiden wants to finish it out. 4/3 is important. You have to flip, and where would that go? Okay, in front of the x is not quite right. Right. Okay, so you're kind of saying it, Leah, like this, right, Leah? So it goes like that, right? Because you're putting the 4/3 into the x. Okay? The reason that's important is because you want to write it like this. Why did I write it like that? Because we took the 4/3 x and we put it in for the x. If you don't do that, you're going to write 4/3, but it's not 4/3, is it? It's 16/9. Is everybody seeing that? This is just to show you that you're plugging in, but you can just plug it in. Like you can just go right to here. There's not done. That's what I'm saying. This needs to be written. This is the answer. Square the 4, square the 3. Of that? Yeah. Like here or here? Yeah. No, because you've already done it. This right here is the function notation of plugging the 4/3 x in for x. This is you doing that. So it wouldn't make sense to put f of that, because that means you're supposed to plug this in again, which that's not how you want to write it. Is that making sense? So this is the function notation. That's plugging it in. That's the answer. Does that make sense? Good questions, guys. Keep it up. I like it when I'm not talking to myself up here. Okay. Okay, take a shot at B. Y equals root x minus 3 after horizontal stretch by a factor of 4 about the y-axis and a vertical stretch by a factor of 2. So it's got 2 stretches. Okay, we're doing both of them. Horizontal stretch by a factor of 4. Let's do that first. What does that mean? 1/4 where? Right, we're putting it in with the x. So that means it's going to look something like this. I don't know why I made that so long. Sorry. Looks weird. Yeah, well, we might be able to do something with that. Let's look here. Okay, so that's the horizontal stretch. What does the vertical stretch do? Right, we put a 2 by the entire thing, and that was a great, who said that? Ty. He said entire thing, not just in front of the radical, right? It's got to be times the whole group. That's really important. Okay, a lot of people just put it just in front of there like a slope. The 2 hits the whole function. We have 2 terms, right? So both terms are getting hit with the 2. Very good. Entire thing's important to say there. So the one thing you can do here, so Aiden, I think you asked, can we square root 1/4? What's the square root of 1/4? 1/2. So we can write it like this. And then what happens? 2 times 1/2 is just 1, right? And then 2 times -3. So your answer is that. Where'd the 2 and 1/2 go? Remember, 2 times 1/2 is 1. Okay. All right, I'm going to pause the video. I want you to take a shot without me talking on C and see how you can do. Just, it's okay if you miss it. Missing's fine. Okay. All right, so it says y equals 3x plus 7 after a vertical stretch above the x-axis by a factor of 1/3 and a reflection in the x-axis. What is nice about this is that the 1/3 and the reflection in the x-axis are with the same number, right? Because the 1/3 is the, it says, see how it says about the x-axis? And then we're reflecting with the x-axis. So that means they're essentially with the same number set, with A. A is the number that we're dealing with, right? And so with that, we don't have to really think about it as a combination. We simply, instead of just having 1/3, we have what? -1/3. So it's simply this. -1/3 times the group, right? Okay, 1/3 because that's the vertical stretch, the negative because that's the vertical flip. Okay, when I say vertical, I know it's over x, but I think it's a flip up and down, right? Okay, so that distributed in, so your final answer would be -x minus 7/3. -x minus 7/3. All right. Okay, we should have a couple more examples. And that's it for this one. We'll take a little short recess here, and then we'll do the lesson 7. Okay, so next page. All right, so describe how the graph of the second function compares to the graph of the first function. So we're just gonna, how do they compare? So you're going to use the words now. A lot of you guys kind of missed in your quiz. You didn't put the words. You just you said like reflect, but reflect over what? Okay, you'll be specific in what it's doing because it can reflect over the x or reflect over the y. So in this case, this one is in the form of what type of stretch? Horizontal. So we know it's a horizontal stretch. Of what? 2, good. About the y. Okay, and that's it. So I wrote a horizontal stretch of 2 about the y-axis. Now we're starting to challenge this. It's a kind of a weird function. It's an exponential function. But what's happening? What changed? Yeah, it's still horizontal. Even though this looks like a weird function, we still see x went to 3x. So that means a 3 went with the x, which makes you feel that you have a horizontal. And the factor is what? 1/3. Good. All right, good work. Okay, how do we feel about C? Good. See how the x's didn't change? Just out in front did? That's our sign it's vertical. Remember, that's normal of 2, but it also has a reflection. Yep, a negative, so it's a reflection about the x-axis. Good. And I don't really like it when they do this. They just left it on the y side. I'm just going to go ahead and divide this 3 over so I can see what it is. It's a little easier for me to see. So if I divide that over, that's going to make it y equals 1/3 x cubed. So now I can kind of see what's happening. Did the x change at all? No, the x didn't change at all. Okay, if you're wondering how I got 1/3, you divide by 3, right? This is the same thing as this. X cubed over 3 is the same thing as 1/3 x cubed. Okay. Right, nothing happened to the x, so we have a vertical stretch. Stay out of the shadow here. Of 1/3 about the x-axis. Yeah, most likely, unless it's a linear, because if it's linear, they might not put brackets because there's no exponent. But when there's exponents, you're going to need brackets, right, to show it was inserted. But yeah. So like on E here, there's 2 now, right? We have something outside and something inside. So we're looking at a vertical and a horizontal. Okay, so this one, it's going to be vertical. You can start abbreviating to vertical stretch of 2. And then you put about the x-axis. You get a horizontal. Jeez Louise, pen was not right there. Let's try this again here. Horizontal stretch of, what's the horizontal stretch of? 3, good. About the y-axis. Okay, and the last one here, is that horizontal or vertical? Horizontal. Of 1/2 the y-axis. Okay, and we also have a reflection over what? Good. Yeah, you still have the reflection over the y-axis. And what's silly about that one, it's a very good point, Aiden. Since the absolute value, if you reflect that over the y-axis, is it going to change at all? No, and that actually was one of the ones on your homework, is that if you have like a parabola right here, and I reflect this parabola over the y-axis, nothing really happens. They essentially just go, it's symmetric there. Same thing with the absolute value there. It's going to be the same thing, Aiden. It's going to land on itself. So you're saying it's flipped onto itself, which really won't do anything. Okay? So when it's symmetric about the y, that's what's going to happen. Okay? Great point. Anything else? Do you have something, Bobber? I had something. Okay. If it comes back to you, just let me know. All right, here we go. Let's look at these guys. Function represented by the thick line is a stretch of the function represented by the thin line. So the thin line is the original. Write an equation for each function represented by the thick line. So we're saying what happened. So this time we have 6 over x squared plus 1. 6 over x squared plus 1. So what are we seeing here? So for example, let's look. What is this at for y? 3, yeah. And then what's this at? 6, right? So their y-intercepts changed. So what's that a trigger for you to think what type of stretch it is? If their y-intercepts change, then what type of stretch is that going to be? Vertical. So you're thinking vertical stretch. Well, if it went from 6 to 3, it got smaller. So your vertical stretch is going to be 1/2. So you're essentially going to times this. You can do it this way. This is how the book does it. You don't have to, I don't think. But you're going to divide by 2, right? And so that's going to be 1/2 times this. And you can leave it like that so you can see the stretch if you'd like. If you did distribute the 2, it would hit these 2. Okay, but you can leave like that so you see the vertical stretch. That's it. It's the function times by 1/2 because that was the stretch. It went from 6 to 3 for the y-intercept. It's the giveaway. Again, how you want to approach this. The vertical stretch is a giveaway because the y-intercepts change. You can't really see the x-intercepts, right? Because they're approaching an asymptote as y. They're not going to cross 0, so there actually is no x-intercepts there. But you can see they have the same behavior. See that? They're essentially going to be going in the same spots, okay? All right, let's look at this weird one over here. All right, so it's kind of hard to see, but here's the thin line right here. And then you can see the thick lines kind of flip there. So it looks like there was some type of flip. Okay. It looks like this goes here too. Looks like it's like this, and then it's like this. Okay. So again on this one, a giveaway is the y-intercepts changed. Okay, but they both look like they changed. So let's look here. So this one's y-intercept. I'm going to say that looks like about 2. And this one looks like 1, 2, 3, 4, 5, 6. Looks like it was 2 to negative 6. Let's make sure I got this right here. So 2. Okay. Yeah, the x-intercept changed too, so there's going to be 2 different ones, yep. So we either have a reflection or we have a stretch, so we have to kind of figure that out here. All right, let me look at it real quick. It's off camera here. Glad it's off camera for Cole's sake. Okay, so we see right here, this right here is at 1, and this over here, the same end spot of that rounded piece, is at negative 2. So when we see that, it went 1 to negative 2. It gives me a stretch of 2 with a reflection about the x to get down here, but then I have to reflect over the y. So that's my movements. So how can I do that with the f of x function? Well, it would be y equals negative f of, whoops, not negative, I gotta get the, we said vertical stretch, right? So that means a negative what? 2 f of negative x. Let's go and try another point. Let's see if I can find another one that kind of works. Let's look at the let's look at this endpoint here. So this guy and this one. So that one's at negative 2. Yeah, and that one's at 4. See that? So negative 2 to 4. What's 4 divided by negative 2? What's both of 4? This one? Oh, yeah, for the x? 3. Oh, no, it's at 3. Is it? Okay, I'll have to look at it. This one's the one that makes sense, though. The point is, though, the y should be at 2. Is your y at negative 2? Yeah. Okay, so your y is at negative 2. This one's at positive 4. So what's 4 divided by negative 2? It gets us this negative 2 again for the vertical stretch, is my point. Okay, so I can look at your book. That's weird if yours is 1 off and mine's not. Okay, C. Okay, so we have, okay, they give us a function, x plus 4, x minus 2, x minus 6. Now, look at this right now. It's a very good picture of what happened. What's changing? Horizontal, right? My x-intercepts are changing. You can see it right there. Okay, so now what's it changing by? So it went from 4, or negative 4, 2, and 6 to 1, 2, 3, 4. So it's going to be negative 8. So negative 4 went to negative 8. 2 went to 4. And 4 went to 8. That's pretty clear. What's horizontal stretch? 2. Horizontal stretch is 2. So that means that we want to, now this is tricky because there's 3 x's there. So what are we going to do? What's that? Yep. Yep. 1/2 where all the x's are. So you're going to have to go like this. You're going to go 1/2, come on, x plus 4, 1/2 x minus 2, 1/2 x minus 6. So you can leave it like that if you want. You could also simplify it in the sense, too, where you could pull 1/2 of all 3, so you don't have the 1/2s there. And that would get you a 1/8 out in front, because 1/2 cubed. I'm fine with that. It doesn't appear there's any vertical stretch. What's the giveaway? What's the giveaway there's no vertical stretch? The y-intercept's the same. See it? How they cross together? So that means there was no movement here. It's just this way.
Also, just the fact that it's thicker, it didn't move. It looks different, but it's not.
Right. It's just going through at a bigger spot because it's just bigger. Yeah, but they're going through the same spot. Yeah, the rope does look bigger, but Bobber, the other thing you can see how those aren't the same, right? You could also look at the top and bottoms. See this right here? Those are the same height. Those are the same height. So that's a giveaway as well. There's no vertical stretch. Really? I'll have to look at your guys' book. That's a little bit of issues. Okay, last example, and we'll take a short little 1-2 minute break here. All right, so example 4, polynomial function has the equation of p of x, x minus 4, x plus 3, x plus 6. That's the one we just looked at, isn't it? Yep, nope, not quite. Okay, determine the zeros and the y-intercepts of the following transformations are applied. So here's the thing. The zeros, there's challenging you. The zeros are the what? The x-intercepts. That is a vertical stretch. Will your x-intercepts change? No. So these zeros, it's already factored for you. You're done. Right? So let's just fix that. So what I want you to write here, just for your notes, this is almost like, this is your notes. No x-intercept change for this one. Right? No x-intercept change, so the x-intercept for this one is going to be 4, -3, and -6. We'll do the stuff that changes last. Okay? What's not going to change here? Yeah, no y-intercept change. Okay, the y-intercept is -4 times -3 is -12 times 6, so the y-intercept is -72. So that won't change. Now let's do the stuff that's going to change. Do you guys see, this goes back to that diploma question we did. This times this gives me my y-intercept, right? That gets me that constant that's going to be on the end. Okay? Now if I'm multiplying that whole thing by -3, how do I change that? So if -72 is normally it, if I'm times the function by -3, what do? I just times that by -3, right? That's my new y-intercept. Okay? Now this makes sense because you guys see the -3. -3 is also a what? A reflection. We went from -72 to positive 216. The y-intercept will be -3 times -72, so 216 is your new y-intercept. So it was stretched by a factor of 3, and it was flipped to positive. Okay, so that's how those numbers should make sense to you. Now our x-intercept here will change. So we have to do this one a little bit more work. We have to go put the -1/2 x in for all of them. Whoops. That's a plus. Okay, +6. We have to find the zeros of all of these. We have to find the zeros of all of these again. They're not as straightforward as just looking at opposite, right? So like for example, this one is, you can set them all equal to 0, is fine if you need to. Add the 4. Times by -2. So one of our new zeros is 8, or -8. Okay? And you don't have to do that really, because why? I just kind of proved how they do it mathematically, but -8, it used to be what? 4. What'd they do to it? multiplied by -2, right? Because that's where our horizontal stretch is. That's all we have to do. What's -3 times, or -3 times -2? 6. And then -6 times -2, 12. And so that's your new zeros. Okay? All right, so that's it for this one.